Alright, in this video we're going to be practicing polar coordinates, looking at slopes of polar curves and other like rate of change type problems, like calculus problems for polar. So first we're going to, very standard problem, find the slope of the polar curve, r equals half theta at the point where theta equals pi over 2, and this will not require a calculator. A lot of these will, so I've got the calculator ready in the bottom of the screen, but this will not be one of them. So we're going to start off with the formula for x and for y. And so that'll be x is r cosine theta, and y is r sine theta. Okay, those are going to be like the two most important formulas for us today. So that means x is half theta cosine theta, and y is 1/2 theta sine theta. We're going to take the derivative of each of these with the product rule. I'm taking the derivative of one and leaving the other one the same, and then adding, leaving the first one the same, and taking the derivative of the other one. Okay, and then I'm going to plug in theta equals pi over 2. I'm going to think about pi over 2 on the unit circle. That's up here at the top. That's the point where x is 0 and y is 1. So any of the cosines are going to be 0 and any of the sines are going to be 1. So x prime of pi over 2 is going to equal half of 0 minus half of pi over 2. So 0 minus 1/2 of pi over 2 times the sine, which was 1. And that's going to be negative pi over 4. And then y prime of pi over 2 is going to equal, okay, 1/2 of 1 plus, that has got a 0 in it, so it's going to be 0. And that'll be a half. And if I want to find dy dx, I'm going to divide those two things by each other. So dy dx at the point where theta is pi over 2 is going to be equal to y prime, which was 1/2, divided by x prime, which was negative pi over 4. And if you wanted to simplify that, that would be 1/2 times negative 4 over pi. And so that would be negative 2 divided by pi. And like I say, this was a multiple choice type question, and you need to be able to take it all the way down to that to get the right answer. Okay, now number 2 is a particle motion question, so these are really just related rates. Okay, r equals 1 plus cosine theta, d theta dt equals 3 over 7 for all time t. Yeah, so we need to start with, this equation right here and take the derivative with respect to time. So dr dt is going to equal, the derivative of 1 is 0, the derivative of cosine theta is negative sine theta, and the derivative of theta is d theta dt. Okay, and we're going to, use that d theta dt equals 3 over 7 that we've got right here to substitute for that. And then we'll find the value of dr dt at the point where theta is pi over 6. Okay, so we're just plugging this in. Okay, so dr dt at theta is pi over 6 is going to equal the negative sine of pi over 6 multiplied by d theta dt was 3 over 7. Okay, now I guess I'm going to need to think about pi over 6, and that's like a 30-degree reference angle in the first quadrant. Okay, so the sine is the vertical leg, that's the short side of a 30, 60, 90, so that's going to be a half. Alright, so I've got negative 1/2 times 3 over 7 is going to be negative 3 over 14. So interpret its meaning in the context of the particle's motion. Alright, so as for meaning, okay, r is decreasing. Okay, but in the context of motion, r decreasing means getting closer to the origin, I suppose, provided that r is positive. Okay, so let's just make sure of that. Yeah, 1 plus cosine theta at pi over 6 is going to be 1 plus a positive number. So, yeah, okay. So I'd say because r of pi over 6 is greater than 0, and dr dt at theta equals pi over 6, okay, we don't know the time, this is a related rate problem, is a negative number, the particle is moving toward the origin. All right, now number 3, consider the polar curve r equals 3 cosine 5 theta. At the point where theta equals pi over 6, as theta increases, is the curve moving toward or away from the origin? All right, so that's kind of the same consideration. We're going to be considering both the sine of r and dr d theta. So r of pi over 6 is going to equal 3 times the cosine of 5 pi over 6. Okay, 5 pi over 6 is almost all the way to pi, so it's just short by pi over 6, so it's going to be this one. And if we're looking for cosine, that's going to be the horizontal leg. That's the longer leg of a 30, 60, 90 triangle. It's going to be root 3 over 2, and it's going to be negative because it's over there in the second quadrant. So this is 3 times negative root 3 over 2 is negative 3 root 3 over 2. So that's a negative number. And then r prime is going to be, let's see, negative 3 sine of 5 theta multiplied by 5 for the chain rule. Okay, so that's negative 15 sine of 5 theta. And then r prime of pi over 6 is going to be negative 15 times the sine of 5 pi over 6. Okay, so that's the vertical leg of that triangle. That's going to be 1/2. Okay, so negative 15 times 1/2 is negative 15 halves. And I would say that, you know, since r and r prime were both negative, r is negative and decreasing. In fact, let me... Okay, I'm pretty sure that 5 theta... Okay, I'm just trying to figure out which... I'm pretty certain it's going to be over here. So r is negative and decreasing, right? So it's getting more negative. And so the curve is going along that way, and you can kind of envision the curve tracing itself out that way. Then I would have, going farther from the origin. Okay, so it's away from the origin. Clearly, to answer the question, r and r prime are negative at theta equals pi over 6. Okay. I figured since I've got the calculator out, I might show you what's going on here. So I've kind of got a polar plotter going on where it's going to start graphing, it graphs up to k, and I'm going to let k run from 0 to just a little bit beyond pi over 6. Now I also have this red dot marked over here where we are, okay, yeah, now you can see my mouse, where the graph is going to be, okay, where we saw that r was negative, and we're going to see that r is negative and decreasing, and so the curve is moving farther away from the origin as it goes to that point. And that's really what I wanted to show you there. Let it do it one more time. That's nice. No, okay, that's great. But I figure I'm probably going to need a polar plotter again later. What is the slope of the line tangent? Okay, so new page, another one of these problems. Okay, we just need to get our practice in. Theta equals pi. So what my recommendation, it might be tempting to distribute in the cosine theta and the sine theta, but I actually recommend when you have one of these things and it has like a constant subtracted, that you just use the product rule, because you're going to have to use the product rule anyway, and the derivative of that -2 is going to be 0. So my suggestion is, at least the first time we're doing this, always write out the formula. X equals r cosine theta, y is r sine theta. Definitely need to be remembering those. But that means x is going to be, now I'm just going to leave it as 3 cosine theta subtract 2 multiplied by cosine theta, and I think that's going to make my life a little bit easier. And y is going to be 3 cosine theta minus 2 times sine theta. Also, when we go to plug in pi, kind of like the object in parentheses and the derivative of the object in parentheses will like be kind of the same, and it'll make the calculation somewhat less treacherous, is what I would say. All right, so x prime, first I'm going to take the derivative of the thing in parentheses, and I would have negative 3 sine theta and leave cosine the same. Okay. And then I'm going to add, leaving the thing in parentheses the same, taking the derivative of cosine theta, which would be negative sine theta, so negative 3 cosine theta minus 2 times sine theta, right? And then y prime is going to equal, okay, the derivative of the thing in the parentheses is still going to be negative 3 sine theta, but then I'm going to multiply by another sine theta, so it'll be sine squared theta, plus leave this the same, and take the derivative of sine theta, which is going to give me cosine theta. Okay, now I'm going to think about theta equals pi. At theta equals pi, which is the far left edge of the unit circle, that's where cosine is going to be negative 1 and sine is going to be 0. All right, so anything with a sine is going to be 0. So it's going to be 0 and 0. Okay. Okay, so if x prime is 0, that probably means that it's going to have a vertical tangent. Yeah, and y prime is going to be non-zero. Okay, that's nice. So y prime is going to equal negative 3 times 0. So that's going to be 0. Plus 3 times negative 1 minus 2 more is negative 5 times negative 1, and that's going to be 5. Okay, so I'm going to say the slope is vertical, and I'm not going to say it equals 5 over 0. That would be untrue. Because dx d theta equals 0, and at the same time dy d theta is non-zero. All right, but I kind of feel like I should plot this just to make sure. 3 cosine theta minus 2. Okay, we're going to let k go up to 1 pi. And let's just see what happens as it hits that. Yep, it was going vertical. Okay, so maybe I let k go to 2 pi, and we'll just watch it go through pi. Oh, and I forgot to change it to that, which is much preferred. Yep, we're seeing that's a vertical tangent. Okay, that's nice. All right, then a particle moves along the polar curve f of theta equals theta plus 1 in such a way, okay, the particle moving, that's going to be another one of these related rate questions, so just like prepare to take the derivative of f of theta equals theta plus 1 with respect to time. And in this case, r is f of theta. What rate is x changing with respect to t? Okay, so r equals theta plus 1. Okay, we want dx dt. So x equals r cosine theta, which means x is theta plus 1 cosine theta. Yes, and then I will have dx dt Okay, I mean, you could take the derivative of this implicitly, trying to remember that each time you took the derivative of something with respect to theta, you needed d theta dt. Dx dt equals dx d theta multiplied by d theta dt. I can just take the derivative of x and then multiply by d theta dt at the end, which is what I'm going to do. All right, so I am also going to move this over here. So dx d theta, just taking the derivative of this regularly, I'd take the derivative of the thing in parentheses, I'd get 1, leave cosine theta the same, then add, leaving the thing in parentheses the same, taking the derivative of cosine theta, which is going to be the negative sine theta. And all right. Yeah, I think I'm going to say, at 5 pi over 6, we're going to have, okay, again with 5 pi over 6, but we've already made the trig diagram, so maybe that's a good idea. So the short leg, long leg, hypotenuse. Okay, so cosine theta, negative root 3 over 2 times, wait, no, minus theta plus 1 sine theta. What's going on here, and what was I thinking? This must be a calculator question. Yeah. Okay, so yeah, because like look at that number. That's possibly one of the worst numbers I've ever seen, and I'm feeling pretty confident that's the worst number I've seen this year. So I'm going to kind of take a couple of steps back and declare this one to be a calculator active question, and then just kind of go from there. So if I've got x equals theta plus 1 cosine theta, and I want to just take a derivative, I'm just going to type that in as an f of x. F of x equals x plus 1 cosine x. Okay, and I don't need that graph. I really am just going to need f prime of 5 pi over 6. All right, and I'm going to report that. I'm going to say dx d theta, because that's really what I did. I took the derivative of that x equation with respect to theta at 5 pi over 6 is going to equal negative 2.675. Okay, and then I'm going to use kind of this equation right here to tell me, okay, then dx dt at 5 pi over 6 is going to be that negative 2.675 multiplied by 2, and okay, it's had the next decimal is 0 on the calculator, so that's negative 5.350. Okay, yeah, but that one was definitely much better with a calculator. Okay, and here's another one that involves a calculator, so I'm almost certainly, I'm going to need to type that in. R equals the square root of 1 plus e to the theta. Yeah, I really recommend, whether I'm using a polar plotter to demonstrate something for you or not, I do recommend typing these in as f of x and then typing in r equals f of theta to graph it, kind of like you can type in f of x and then type y equals f prime of x if you need to graph the derivative for some reason, like find a point of inflection or whatever. 1 plus e to the x. All right, and then what are the xy coordinates of the point on the curve corresponding to theta equals 2? Okay, well this is just kind of a calculator thing, right? I need x and y. X equals r cosine theta, y equals r sine theta. And so at theta equals 2, start with these, and then at theta equals 2, have x of 2 equals the square root, r of 2, 1 plus e to the 2 times the cosine of 2, and y is going to equal the square root of 1 plus e to the 2 times sine of 2. And you could type it in like that, but we probably don't need to do that. You can just do f of 2 cosine 2, okay, and get negative 1.205. And then just change out the cosine to be a sine and get 2.634. Okay, but we didn't really need the graph. Okay, I don't think that I kind of was working with that earlier when I was trying to do that in the first polar plotting to have that fixed point for it to go through. And I kind of realized that it doesn't plot points when if you put in the parentheses, it thinks it's x and y, not r and theta. And so you have to use those formulas that I've highlighted. You have to use your math knowledge to actually be able to plot things polarly, but that involves just a cosine theta and a sine theta multiplied by your r coordinates. All right. So what is the value of theta that corresponds to the point on the curve with x coordinate -4? So x equals -4. That means our cosine theta equals -4. And this is the type of problem that I wonder is this still a Cal BC question, or is this AP Pre-Cal now? Because this is definitely the type of problem that they could solve in the AP Pre-Cal class. R equals the square root of 1 plus e to the theta. Pretty sure, we've already got r defined, so I don't think this third line is totally necessary as justification for my equation solving here. But what I'm going to do is I'm going to actually graph r cosine theta, so f y equals f of x cosine x, and I'll just see what is the value of theta. Is there some sort of restriction? Yeah, 0 to pi. So I am going to actually do that, 0 less than x less than pi. Okay, great. And then I see it running through -4, y equals -4. We see that. We're going to find the intersection, record that, and that's -2.819 or -2.820. Yeah, 2. Positive 2. Theta equals 2.820. And that's the value of theta. And at what value of theta does the curve have a horizontal tangent? Okay, that's where dy d theta equals 0. Okay, and we're just going to have faith that dx d theta is not also 0 at that point because, well, it would not be a horizontal tangent there. So dy d theta equals 0. On 0 to pi, I'm going to need to graph y prime. So I think I'm going to get rid of all of these. Okay, y is equal, and I'm going to say, how do you do that? Yeah, y equals g of x. That's just my note that, this is what's happening here. So g of x equals f of x sine x. Okay, that's still not what I want. I want the derivative of this thing to equal 0. I want the derivative of y to equal 0. I've defined y here. Y equals g prime of x. I'm using y to mean more than one thing, but if I say this on 0 to pi, then there's only one place where this is equal to 0. Now, I feel like I'm realizing, okay, yeah, that's that negative, or that's 1.985, and that's great. Say dy d theta equals 0, I might write in what y equals square root of 1 plus e to the theta sine theta. But you could also say y equals r sine theta, and that would make just as much sense. And that's what gave me theta equals 1.985 with the calculator. But, I'm realizing, I'm just coming from the, having always used the TI-84, you wanted to graph the derivative and see where it equaled 0. And that's great, see it goes from positive to negative. That's totally irrelevant to us. I thought I was thinking about something else. That'll come later. But I feel like we might not have needed to, let's cut that. Might not have actually needed to graph the derivative. Yeah, we could have just gone and touched the maximum there and seen, okay, where the slope of y is 0 is 1.985. And I just got to get used to that being actually reliable because it wasn't as reliable on a TI-84. All right, so we're back to some no calculator questions. F is a differentiable function with f of pi equals -8 and f prime of pi equals 9. What's the slope of the line tangent to the polar curve f theta? You would think that's not enough information, but it actually is. So what I'm going to say is, always start the same way. X is our cosine theta and y is our sine theta. Okay, and in this case, r is f of theta. Okay, so I'm just going to say x prime is going to equal r prime cosine theta minus r sine theta, because then we're just going to plug in these values. And then y is going to be r prime sine theta plus r cosine theta. Just going to use the product rule. Okay, now I've got r equaling -8 and r prime equaling +9. Okay, might as well say at theta equals pi, cosine theta equals -1 and sine theta equals 0. And this is all, at theta equals pi. So now I'm just going to plug in the stuff and say x prime is equal to 9 times -1 minus -8 times 0, and y prime, I didn't say prime, but I meant to, is r prime times sine theta plus r times cosine theta. And so I've got -9 over here and +8 over there. And so dy dx at theta equals pi would be 8 over -9. I like that problem type. That's a good one. Okay, and then at the point where theta equals pi, as theta increases, is the curve moving toward or away from the origin? Once again, the same kind of concept. Okay, so r is negative, but increasing, so getting closer to 0. And r equals 0 is the origin, so it looks like I'm moving toward the origin. Let's say, all right, it's going to be toward. I'm going to clearly answer the question. Because at theta equals pi, r is negative and dr d theta is positive. All right, now number 11, the particle moves along the portion of the polar curve. That one looks interesting. Corresponding to pi over 4 to pi over 2 in such a way that the distance between the particle and the origin decreases at a constant rate of 0.2 units per second. Find the rate at which the angle theta changes with respect to time at the instant when theta equals 1. This is another one I feel like might need to be a calculator, but I'll try to use the quotient rule. Yeah, the distance between the particle and the origin decreases 0.2 units per second. That's going to be dr dt is -0.2. And we can see that between pi over 4 and pi over 2, r is definitely going to be positive because it's a positive number in the numerator and a positive number in the denominator. Okay, so it's going to be positive everywhere it's defined. So I'm going to say, all right, once again, dr dt is going to equal dr d theta multiplied by d theta dt. Now that's what we are eventually hoping to solve for, right? Find the rate at which the angle theta changes with respect to time. That's d theta dt. So that's what we're hoping to solve for eventually. So I just need to take the derivative of r. So dr d theta is going to be bottom times the derivative of the top. And because theta equals 1, this won't be too bad. Minus the top times the derivative of the bottom divided by the bottom squared. And this was any value besides theta equals 1. This would be pretty rough, but I think we're going to be all right. R prime of 1 is going to be theta to the 4 plus 1 times a half minus the square root of 1 times 4 divided by 1, and 1 is 2 squared. Okay, so that's 1 minus 4 is -3 divided by 4. Okay, that's not bad. Okay, so dr dt, which we already knew was 0.2, equals dr d theta, which was negative 3/4, times d theta dt. So it'd be 4/3 of 0.2. But that's not going to be a very nice decimal, so maybe I'll go in and just change the 0.2 to a 1/5. Multiply both sides by 4, divide both sides by negative 3, and I'll say d theta dt at theta equals 1, which I probably should have labeled there. That's going to equal, so 4 over negative 15. All right. And this one, okay, yeah, vertical tangent, yeah, that's definitely going to require a calculator. Okay, so vertical tangent, that's where dx d theta equals 0. All right, we're going to need a formula for x. X equals r theta log theta cosine theta. And then we're going to say, okay, we're going to use the calculator and we're going to kind of program this in as the function we're interested in, and we're going to use that domain restriction. Okay, so f of x equal to x log x cosine x. That's an interesting function. Between 0 and pi over 4. Okay, great. And okay, and if that's the function and we're interested in where its derivative equals 0, we can just zoom on in, and there it is, 0.325. Okay, now if you were not trusting that and you wanted to know where the derivative of this thing was equal to 0, then you would go and you would graph the derivative and it would look different. When you found the derivative, I mean the 0, that would be the same spot. Okay, 0.325. All right, now consider the polar curve r equals sine 3 theta plus 2 for theta between 0 and pi. Okay, sine of 3 theta plus 2. Okay, I'm going to actually go back to home. Then average distance from the curve to the origin, that's going to be average value of r. On the interval 0 to pi. Okay, so that's going to be, we're going to integrate r from 0 to pi and divide by pi minus 0. So r of theta d theta. Okay, couldn't do a whole homework without integrating it all, so I'm going to go up here and say, okay, I've got it plugged in, sine 3 theta plus 2. We're going to do 1 over pi times the integral from 0 to pi of f of x dx, and that'll give me 3.783. All right, and then find the value of theta going from 0 to pi, and the closed interval that corresponds to the point on the curve closest to the origin. Okay, so we can see it's probably right there. Okay, but we're going to need to figure out what that theta value is. Okay, and we're going to need to justify our answer as well. Okay, so we're going to give us a closed interval. We're going to need to do the closed interval test. So we're going to make ourselves a table. Okay, theta and r. Okay, we're definitely going to need to check theta equals 0 and theta equals pi, but there will also be some other values that we might need to check. So I'm going to, and I'm going to also make kind of my mirror table over here. I'm going to have x1 and f of x1. And that will really speed things up for me, 0, pi, and then I'm going to need to go and find any other values. Okay, you can turn that off if you don't want to look at that, but I'll fill in a table since I've got the calculator. 2 and 5.142. And then we're going to look at places where r prime is equal to 0. And those are going to be critical points. So, f prime of x is going to exist everywhere. So I'm going to go over and I'm going to graph y equals f prime of x. Oh, but only on the interval 0 to pi. Now, unfortunately, we are going to have 3 values. Okay, yes, I remember making this problem. Okay, so what we need to do is save all 3 of them. Okay, now only one of them is a local minimum. And so I understand the temptation to try to, exclude the other 2. But if you want the points on the free response section, I'm just going to recommend, especially with a calculator, just do this. Like I'm using cut and paste. I'm cutting Control X, Control V right there. It is just filling in the table. This is barely even calculus, There we go. So we can copy in those numbers. It's so much easier and faster than it used to be. I just think this is great. So theta equals 0.637. Or actually, I'm going to say 0.636 ... and 1.457 and 2.731. Okay, and I'm going to, plug those in. Is that the order I put them in the table? Yeah, okay, so 0.637, because theta is going to be our answer. 1.458 and 2.731 gave us values of 3580 and 2.515. Okay, I'm seeing what's happening now. 5.674. I didn't notice that before. Okay, so we do need to make sure that all of those numbers are accurate in order to get our justification points. Okay, I would obviously never put this on my test because I don't want to have to check all of those decimal values, right? That would be crazy. And all of that for closest to the origin is the lowest absolute value of r. That's at theta equals 0. Okay, so that's kind of let down, but that is prone to happening sometimes. You can have an endpoint extreme. That's why we do the closed interval test. So, okay, there we go. We did one. Okay, and then another one of these. Okay, yeah, because we're just down at the very end of the homework, and I knew I needed to do at least 2 of these absolute extrema questions. There we go. So I'm going to kind of just start from scratch those and do the same process again. Okay, so I'm given this polar curve. I'm going to type it in as a function of x. So x sine of x all divided by 2. Then add 1. I almost didn't see that. Greatest distance from the origin. So I'm going to need a table and do a candidates test. I'm going to turn that off. And really the key is the first step. We turn that into f of x1. And we're definitely going to plug in 0 and pi. Okay, so we get 1 and 1. So both of these are 1. Okay, greatest distance from the origin to the graph. Okay, and then... Okay, well, we're going to need to figure out where r prime is equal to 0. R prime equals 0. That's going to give me some, I don't know how many theta values. Maybe I'll just graph r equals f of theta. I'm kind of just curious. Okay, 0 to 12 pi, that's pretty cool. Let's say 0 to 1 pi, okay, less cool, okay, but, something to investigate a different time. And So r prime equals 0. Yeah, that does really nothing for me, right? You can see that there's probably like a farthest out spot somewhere over here-ish. But we can see that it's definitely farther than 1 unit away from the origin up here, so there's going to be some farthest out spot. Okay, but that's totally unhelpful, was kind of the point I had. And what we need to do is we need to graph y equals f prime of x on the interval 0 to pi. That happened at theta equals 0, but we already got that one in our table, so we need to have 2.20282.02876. Rather than typing it, we're going to cut and paste it so we don't transcribe anything wrong. And that'd be like the digital version of a copy error. Okay, so we got 2.028 dot, and then I have that 2.02, that's 0.29 if we're rounding, get 1.909 or 910. Okay, so the greatest distance, we have to be very careful about what they're asking for, is going to be 1.910. Right, and then the last one, also calculator, certain polar curve r equals f of theta. It's known that dx d theta and dy d theta. Okay, I was waiting for this one. I actually forgot about it, but I knew that I wanted to do this one on the homework. I had one of these on the old homework, thinking that it wasn't really possible. But then I kind of come to realize that, maybe it'd be a stretch, but this could be considered Cal BC because polar curves are parametric, and we have to find the second derivative of parametric curves, the second derivative of y with respect to x, and find the second derivative of everything, really. But we do have to find the second derivative of y with respect to x on parametric curves, and that could extend to polar. So what we're going to do is we're going to get an expression for dy dx. And that's going to be dy d theta okay, and we're going to be dividing that by dx d theta, which is cosine theta over theta, plus, minus. So minus sine theta log theta. And if you look closely, you can probably see what the original f of theta would be, but that's not really all that relevant. Okay, what we're really gonna need to use leverage the calculator for this, and so I'm just gonna clear out everything. What we want to do is we want to take the derivative of this and then divide by dx dt. So I think what we would be wise to do is define f of x, g of x, and h of x. Okay, but I'm not going to write that down. Now, this would definitely be a multiple choice question if it was something we were going to be tested on. But I'm going to put dx d theta cosine divided by x minus sine of x log x. Okay, cool. G of x is going to be dy d theta sine of x divided by x plus cosine x log x. Take a, okay, that's definitely interesting. Interesting graphs. Okay, just going to go and turn those off because they're not helping. H of x is going to be dy dx. So that's going to be y prime divided by x prime. Okay, and that looks awfully familiar. It looks like the graph of y equals tangent x. But with some intrigue over here. But that's really not even what we don't need the graph of that either. We need to take the derivative of h and then divide by dx d theta. So that's what we're going to, basically, that's going to be our second derivative calculator right there. But I'm going to write in what we're doing. Second derivative of y with respect to x at theta equals 3 is going to be the derivative with respect to theta of that expression up above, the massive fraction I'm calling dy dx. I'm also calling h of x in Desmos at theta equals 3 divided by dx d theta at theta equals 3. And that's what I'm going to be plugging into the calculator, and I'm going to get negative 13.594. Oh, and it's like totally all the room I've got. So negative 13.594. That's making it worse. Okay, I can just hold it up there. Okay, so that's the last problem. That's going to be all for this video. Thanks for watching.